All right, kids, this is question 4 from Graphing Rational Functions 1. That's Tuesday's assignment. The first thing we do with any rational function is we look to see if it's factorable. Neither of these polynomial expressions are factorable, so I'm not going to factor it. I also notice that there are no common factors. It's not factorable and we don't have anything in common. And what that means is there are no wholes. Now, we're not going to just skip that. We're still going to note that there aren't any, so I'm going to say no wholes. And that's important. We don't want to forget to find wholes where they exist. So if there aren't any, we want to note that there aren't so that you don't forget that important first step. After we've established that there are no wholes, the next thing we do is we find our vertical asymptotes. Find vertical asymptotes by setting the bottom of our function equal to 0. So this is 2x squared minus 1 is equal to 0. And I'm going to solve for x. So I get 2x squared is equal to 1, and x squared is equal to 1/2. What do I do at this point? Well, I have x squared is equal to 1/2. In order to get the x alone, what I have to do is take the square root. So x is equal to plus or minus square root of 1/2. Now that is not a particularly helpful number to us. Yes, it is the most accurate representation of that number, but if I'm going to graph this, then I need a decimal. And so what we're going to do is we're going to turn to our calculator and we're going to find the square root of 1/2. The square root of 1/2 is 0.707106. It goes on because it's an irrational, well, square root of 2 is an irrational number. But for our purposes, we're just going to take the first decimal place because it's something we've got to graph. So we have vertical asymptotes at positive and negative 0.7. Okay, and if you want to go as far as to say, okay, x equals 0.7 and x equals negative 0.7, that's probably better because how many vertical asymptotes do we have? We have 2. Okay, so separating them out might ensure that you don't forget to graph both of them. All right, that's our vertical asymptote. And then what we're going to do is we're going to find our horizontal asymptote. And remember, we find horizontal asymptotes by comparing the exponent on the top with the exponent on the bottom. My top exponent is 3 and my bottom is 2. And what does that mean? That means that there's no horizontal asymptote, but there is an oblique. Exclamation point, because we're excited that we get to find an oblique asymptote. And remember, you find oblique asymptotes by dividing the top by the bottom. So I'm going to use 2x squared minus 1, and I'm going to put the x cubed on the inside of the house. Remember that you need placeholders, so it's x cubed plus 0x squared plus 0x plus 5. Got to have those placeholders, okay? And then I ask, all right, what can I multiply by 2x squared to give me x cubed, 1x cubed? And the answer is 1/2 x. 1/2 x times 2x squared is just x cubed. 1/2 x times negative 1 is negative 1/2 x. What did I forget, guys? I totally forgot the placeholder on the divisor. What was I thinking? Such a good thing I'm writing in pencil, isn't it? This is why we do this, right? Okay, so this is 2x squared plus 0x minus 1. Again, it's a 1/2 x here. So this is x cubed plus 0x squared minus 1/2 x. And then what I do is I switch the signs, right? I subtract. So subtraction, this is a minus, and this one becomes a plus. And I end up with 1/2 x plus 5. That is my remainder. But remember, at this point, for what we're doing here, the remainder, it does not matter to us. What I'm interested in is this right here, my quotient, okay? So right there, my quotient, that's my oblique asymptote. And so I'm going to note oblique is y equals 1/2 x. x, and that's my oblique asymptote. Way to go, us. How exciting is that, y'all? Okay. The next thing I'm going to find is my x-intercept. And try to find it in this little space over here. We find that by setting the top equal to 0, and that's x cubed plus 5 equal to 0. And so x cubed is equal to negative 5. That could happen. You can have a cube root that's a negative number or a cubed number that's negative. Remember, odd powers can be negative, even powers cannot. Okay, so x, we take the cubed root here, guys. X is equal to the cubed root of negative 5. Now, like my vertical asymptotes, that's not a particularly helpful number. And so what I'm going to do is I'm going to find the cubed root of that using my calculator. Now, I'm going to show you, remember that we talked about fractional exponents. If I want the cubed root of negative 5, I say it's negative 5, and we're going to put that in parentheses actually, so that our calculator does not get confused, raised to the 1/3 power. And that's the cubed root. You can also go to math and find the cubed root there. And that's negative 1.709975. Again, because we're graphing this, we're just going to use one decimal extension. So x is negative 1.7. Now remember, that's an x-intercept, so it's a coordinate. So my x-intercept is negative 1.7, 0. And then last is our y-intercept. And I'm going to try to fit it in right here. And guys, this is not a good example of what your work should look like. Certainly I would be able to follow your work if it looked like this, but you do want to give it a little more space. I'm trying to cram it all in here so that you guys can see it all at once, to make it a little easier for you guys to see everything that's happening. All right. So my y-intercept I find by plugging 0 in for x and solving for y. So that's 0 cubed plus 5 over 2 times 0 squared minus 1, and you get 5 over negative 1. And so my y-intercept is negative 5. And remember, that's a coordinate. So it's the coordinate 0, negative 5. Okay. And we found all the things, guys. And so what we're going to do is we're going to graph them. All right, so it's important for you to remember that when you get weird numbers, you should not freak out, okay? So, so what that our vertical asymptote is the square root of 1/2? Who cares? We got calculators, so we're just going to plug it in and get those numbers. I'm going to take a minute and note all these numbers so that when I move the paper down, you can still see them. And now we're going to graph this. Put the page down and we'll graph it. There we go. Okay. Right here. So I'm going to draw my XY axis. My vertical asymptotes are at negative 0.7, so again, it doesn't have to be crazy accurate, but it does need to be between 0 and -1 and closer to -1. There's one of them, and at 0.7. I do not have a horizontal asymptote, but I do have an oblique asymptote. And that oblique asymptote is 1/2 x, so it goes through the point 0, 0. We have a y-intercept of 0, and then we have a slope of 1/2, so up 1 and over 2. And again, you're going to just graph a few points and use those to help guide you drawing the dashed line. Okay. After we draw our oblique, we're going to draw or write our x-intercept and our y-intercept. We've got an x-intercept at negative 1.7 right there. I've got a y-intercept at negative 5. 1, 2, 3, 4. Right here. Okay. And you know, again, this is one of those things where you're going to look at this function and you're going to see what it looks like. I have graphed it in the calculator, and this is what this looks like. We got the two curves on top and then the parabola in between. Okay, so we're going to go ahead and sketch those. Remember that those asymptotes are there to guide the function, and so you want your graphs to sort of stick close to your asymptotes. Now, this function has a domain that stops at the asymptotes. So my domain is negative infinity to negative 0.7, negative 0.7 to positive 0.7, and then positive 0.7 to infinity. That's my domain. My range for this function. Now you may think you're going to need to be calculating maximums and minimums, but you're actually not. And the reason is that this asymptote goes down forever, which means that this graph continues down forever. So the range of this function is negative infinity to positive infinity. There are no breaks. If there were a horizontal asymptote, then we would have to stop for that. But oblique asymptotes don't always affect the range of your function. So our range here is negative infinity to positive infinity. And again, that's because as this asymptote goes down forever, so does my graph. So that graph, this piece right here, this piece has a range from negative infinity to positive infinity. And if any one piece of your graph does that, has that range, then your entire graph does. All right, again, this was question 4 from Graphing Rational Functions 1, and that's Tuesday's assignment.